Example 3. Well, with this example, I just want to give you a sense that when you approach these types of problems, when you're trying to find the area of composite shapes, there isn't one approach only. You can have many different approaches. So here, let's take a look at this example. So you see this composite shape. It looks like two Lego pieces put together, right? All of these are the same shape. Okay, you may want to pause the video and copy them down, but they're different. So consider different shape divisions to calculate the area of the composite shape below, right? So nicely they have labeled a shape for us. So first they've divided this shape into these three rectangles, right? You have area 1, that's one rectangle, area 2, that's another rectangle, and area 3, that's another rectangle. And you will notice that it doesn't matter how you approach it, as long as you're consistent and use the formulas properly, you should get the same answer. So what's the area? What is the area of area 1? Well, area 1 would be 7 times 3. What's 7 times 3? Equals to 21 centimeters square. Right. What about area 2? Let's put here area 2. Well, area 2 is also 7 times 3. So 7 times 3 equals 21 centimeters square. How about area 3? Well, area 3, from here to here, they tell us it's 8. But we don't know what the width of that is. Right? Can we find that out? What the width of that is? Well, yes. If from here to here is 7, and from here to here is 4, then what do you have left? You have 3 centimeters left. So that means 8 times 3. So area 3 is equal to 8 times 3. 8 times 3 is equal to 24 centimeters. Right, and of course, when you add these three areas, so area total, just want to write AT equals to A1 plus A2 plus A3. You add these three areas, so you get 60, 20, 40, 60, 64, 66 centimeters square. Right? So that's the area for the shape. Now, let's say if you divide it in a different way. Let's say that instead of cutting across this way, you decided to create these areas. So now you have area 1, area 2, and area 3. Well, we should get the same answer. And just to show you, here it is. Area 1 is what? 4 times 3. That gives us 12 centimeters square. Area 2 is what? And then again, 4 times 3. So 4 times 3, that gives us 12 centimeters square. What about area 3? Well, the length of area 3 is what? 14. What's the width of this? Well, we found out from previously, but we know what the width is. The width is 3 centimeters. So area 3 would be 14 times 3. Now, what is 14 times 3? That gives us 42 centimeters square. And once again, the total area, if you add area 1 plus area 2 plus area 3, it's equal to 40, 60, 66 once again. And we expect that. We expect to get the same answer. Now let's take a look at our last option. And in this way, in this one, they didn't divide it. Instead, what they have done is, well, what do you see here? What they have done is the following. You have a bigger rectangle, right? I'm tracing it. And then you have a smaller rectangle. So how do you think we would solve this? And they only have area 1 and area 2. Area 1 is the smaller rectangle. Area 2 is the bigger triangle. So maybe pause the video and tell me, how would you solve this? Well, what they're doing is this. Let's find out what area 1 is. Well, area 1 is going to be 8 times 4. So what's 8 times 4? 8 times 4 is 32. What about area 2? Area 2 is what? 14 times 7. Well, what's 14 times 7? You put it in your calculator or try to figure out without a calculator, you get 98 centimeters square. And of course, here I forgot to write the units. And of course, what's the total area? Well, we don't need to find the area here, so that means that we can remove it. In order to find the area of this shape, let me shade it here. In order to find the area of that, we need to subtract the bigger area minus the smaller area. Well, the bigger area is area 2 minus the smaller area, which is area 1. What is the answer for this? Well, 98 minus 32. Well, 98 minus 32 will give us 66 centimeters square. So it doesn't matter how you approach it, we should always get the same answer as long as you are consistent with your calculations.